Hey, Greg.
Hey, happy Saturday, Omar.
Hey.
Hey,
Yeah,
Vice. Ash is up.
Good morning.
Good morning. So nice to hear your voice isn't as hoarse anymore.
No, thankfully.
Yeah, sounds like you're feeling better. Hey, Gugan. Good morning or good evening, venue.
Hey, Omar. Hey, Greg.
Hey, how's it going?
Hello. We'll give everyone a few minutes here. So, Omar, it looks like that the database texting looks interesting that they're doing currently.
Yeah, I think we need to get a little bit more rigorous on how that actually gets done.
Yeah.
But yeah, I mean, he put together an initial, kind of a proof of concept of doing that. And yeah, I mean, I've spent like months at companies sometimes testing like what database to use. That can get pretty involved sometimes.
Yeah.
And there's so many to pick from out there. God,
it's kind of like car shopping, right?
Yeah. Except with cars, it's like, clearly visible and evident. With these databases, it's like nothing's visible. You have to dig in and hunt around for the specs and actually try things out. Yeah.
Very cool. Hey, Siddharth. Thanks for joining us. Hey, Jay.
Hey, good evening, good afternoon, good morning.
Good evening. Yes, we're just waiting for everyone to join and then we'll get started. It's unfortunate Omar can't join the trip to Amsterdam.
Yeah.
It would have been a lot of fun, but that's all right.
Yeah, he was kind of bummed out about that.
Yeah. I know he was super excited to see the Blender Foundation. Sounds like a really cool company, like just this open source group that supports open source developers and contributes to a lot of cool software and builds a lot of cool products. Mm-hmm. I've never seen someone so excited about an open source foundation. It's cool. His interests are cool.
Mm-hmm. I watched a video the other day where he had long hair. He suits long hair. I like it. He looks so cool. It's all like
yeah, that was his COVID style.
Yeah. I watched a video from like 2018. It was like one of the first updates. Then directly into that one, and he looked like a different person. It was incredible.
Yeah.
Funny stuff. Cool. Well, it looks like more people are joining now, so we can go ahead and get started. Omar, what do you want to focus on talking about today?
First of all, kind of open it up for people to like maybe do some introductions and then ask any questions that they have. And then after that, talk a little bit more about some thoughts that I've had on thinking about the node reward system.
Great. Well, it looks like we have some new people joining for the first time today. Hi, Siddharth. Would you like to unmute your mic and introduce yourself?
Yeah, sure. So, I am Siddharth from India, and currently I work in data science domain. I started following cryptocurrencies and blockchain tech stack from last year, and I have also been following still from 2020 itself. So yeah,
awesome.
Looking
so you work in
to contribute.
Very cool.
Yeah.
So you work in data science?
Yeah, I work in data science.
Awesome. Thank you for joining us today, Siddharth.
Yeah.
Hi, Earth. Would you like to unmute your mic and introduce yourself? Okay.
Maybe.
Ram, is that Ram Prasad? Or if you're a different Ram, you can introduce yourself.
It's Ram Prasad.
Hey, Ram.
Hey, hi.
Thanks for joining us. Hi, Earth. Would you like to unmute yourself? I see a popcorn logo. I think that might mean you're just watching us or listening in. I think we met Vajanath last time, but Vajanath, if you want to reintroduce yourself for people like Siddharth who are joining for the first time. And your mic is on mute. Cool. Introductions are always fun in open source communities. And Venue, if you want to unmute yourself and introduce yourself. Great. Alrighty. Well, Siddharth, since it's your first time joining, do you have any questions on the top of your mind just about Shardeum and things you'd like to learn more about?
Discuss more, whatever you have to discuss, maybe you can start.
Okay. Yeah, I guess
Cool.
maybe the roadmap would also be good for us to talk about too, a little bit more about like why we're building the features we are in the order we are, and kind of what the roadmap and the performance in that demo. When you're scaling, it's really cool, but what do you expect that like the performance per node to reach? Do you think we'll get more than 40 TPS at 100 nodes eventually?
Yeah, so basically those transactions to accounts, and those will be a little bit heavier type of transactions than say like just transferring the native coin between two accounts. And so for us, if you just have a single node, and you hit, send it now with the, like if you look on the Ethereum network and you, like if you go to etherscan.io and you look at the graph of their daily transaction count and so forth, if you look at the day, 1,400 seconds per day, you'll notice that on its peak day, it was able to achieve somewhere close to like 20 transactions per second. And I think that's pretty much the limit of what Ethereum can do. It can only, execute so many transactions per second. And with Shardeum, we've also implemented the EVM. Our EVM is not like in Node.js, and so Node.js runs through LLVM, which is like a low-level virtual machine. So it doesn't get the super fast throughput, but still gets pretty good performance. So but that's for a single node. But then what happens with Shardeum is that since we're sharded, we can then multiply that by the number of nodes that we have in the network. So if you had only one node covering each range of data, then it would be 1,000 times the 15, which would get us to like 15,000 transactions per second with 1,000 nodes. But of course, we want redundancy, right? So we don't just want like one node covering each address range, or essentially in Shardeum, it's 100 nodes covering each address. Then we have to divide that by 100. So we then would, have 1,000 divided by 100, which gives us 1,000 nodes. And that's, sounds like it's not a lot, but if you, compare that with, like the Binance Smart Chain and compare it with like Polygon, these this is the limits of what they're getting, then would be at 300 transactions per second.
Mute this person.
Sure.
And it looks like Vajanath has a question. Vajanath, you can unmute yourself and ask that. Although I think he just disconnected. I'm going to mute this person. The new person who just joined, fellow Jitsu, just to let you know, I'm going to mute you because you have some background noise. So if you want to speak, just unmute your mic. Yeah, so I think it, like, obviously, you know, linear scaling adds a lot of value, but was just curious about like squeezing out as much performance as we can out of each node without vertically scaling. Like with the EIP 2930, will that access list help increase the performance per each node? Or also, does the average TPS get higher than 15 TPS when it's not only, you know, smart contract token transfers, when you're doing light peer-to-peer token transfers as well?
Yeah, so when you're doing like native coin transfers, it can get on average, you know, a lot of the transfers or a lot of the transactions will involve like token transfers and, you know, using contracts to do, you know, like, you know, more complex things. And so that'll kind of offset each other, right? So you have some like native coin transfer transactions, but then you have like even heavier, like especially situations where you have like a contract calling another contract, or, you know, you're accessing multiple different accounts. So EIP 2930 allows the transaction to specify what accounts system for this. You know, since we were designing it to be sharded in the beginning, we knew that this would be something that would really help increase the, you know, processing of a transaction. Now, if a transaction comes in and doesn't have an access list, those kind of, you know, the number of accounts that they're accessing times the amount of time it takes a regular transaction to process. So, for example, if a regular transaction, you know, takes about 5 seconds to process, then if a non-EIP 2930 transaction involved, let's say, you know, 3 accounts, then...
It's great that we can solve Ethereum's challenge, and, you know, rather than, you know, having to add layer 2, we can just, you know, we've built a dynamic sharding allows us to scale natively at layer 1 without vertically scaling. But
and by the way, if you didn't hear the news, Ethereum just pushed the merge back.
Oh, they did?
So they were supposed, that got pushed back till second half of 2022.
Cool. Well, yeah, there's definitely some technical complexity there, but of course we're not a project that's like bashing on anyone pushing back their milestones.
Yeah, I mean, you know, the thing is, it's like they initially announced that they're going to do, you know, switch to proof of work in late 20 of work back in late 2019, and it was supposed to happen in like early 2020, right? So we're now, you know, like a full 2 years into it. But yeah, I mean, I'm not bashing, but I'm just saying, like, you know, when you have a network up and running, it's going to get extremely complicated to do these kind of things, because now you have lots of value on that network. One of the advantages that we have with Shardeum is that, you know, we're focusing on the design right from the beginning, and, you know, we can experiment and, you know, do things hopefully the right way right from the beginning, and, you know, it'll hopefully allow us to deliver things on time. And that's one of the things that I'm kind of adamant about, is making sure that we try to deliver on time.
Yep. That's what's attracted me over the years. It's just so many crypto projects out there are money grabs. You know, they're not really building any new technology. They're just promoting some idea just for the sole goal of making money. And Omar, you've always just been product and tech focused and never really cared about the money side of things at all. So that's something really genuine about you. But I'm sure you don't want me to be asking questions the entire time. We want the community to talk. and ask questions. So
Yeah, I
if
think there's like a raise hand button there. So if you guys have any questions, just click that button. That way, Greg will know that you have a question.
It looks like
you can call
it looks like we have some a question in the chat. Since Shardeum is storing all the transactions data in 10 archive nodes, which it'll be more than 10 archive nodes at one point, but since Shardeum's storing all the transaction data in 10 archive nodes, is it possible for someone to take over the archive nodes and erase the data, or impossible?
Well, each archive node has a complete set of data. And then, and so essentially someone would have to take over all 10 at the same time and do something like that. But, then again, one could say, well, look, Binance Smart Chain has 21 nodes that it's running the whole network off of. And what if I DDoS all 21 of those nodes? I could say, what if somebody takes over all 20 of those nodes and so forth? So, these kind of risks are there, but I think sometimes people scare themselves with, things like this where, it's definitely good to think about, but there's probably, in terms of probabilities, the probability of something like that happening is really, really low, right? I mean, you can always talk about possibilities, right? Because like almost everything is possible, right? Like, but we have to think in terms of probabilities, and the probability of something like that happening is extremely low.
Yep, and I think like I was mentioning, I think 5 archive nodes is just for like either the AlphaNet or the beta net, right? But once the mainnet goes live, we're going to have more than 5 archive nodes as well. So the probability even drops farther as there are more and more of them. Yeah,
exactly. So we're thinking of having like maybe around, 5% of the validators. 5% of that would be like archive nodes. So like if you had 1,000 validators, you'd have about 50 archive nodes.
Awesome.
And that might grow kind of like non-linearly, where you don't after about like say 200 to 300 archive nodes, you really don't keep having to add so many archive nodes, right? Because redundancy, you after a certain amount of redundancy, you just kind of like you can get into an area where you have like excess redundancy that's not really buying you anything more. Like for every new node that you add for redundancy, it doesn't get you as much, bang for how much you're spending. So
yep. You get to a point where you have enough redundancy where you're safe and secure, and any more redundancy just waste network costs, right? Because it's just unnecessary redundancy, and you have to reward the node for what it's doing, right. And you don't need to know.
Yeah, I think like in the Ethereum community, there was some research done on what's a good level of redundancy for public networks, especially since they were thinking of doing they are doing data sharding now, but they wanted to know like what should be the shard size, and I think they came to the conclusion that having 100 nodes is definite. Well, you definitely should have 100 nodes, but then having more than 300 nodes is like an overkill. Mm-hmm. So the sweet spot is somewhere between that.
Yeah, I think these questions are so fascinating that are being asked for the first time. Like, what's the best token reward distribution schedule? What's the correct amount of nodes for redundancy to be optimized for security, but still not wasting network costs? I wish I had the mathematical education to find the answers to these questions. But if I was a consulting company, that would be a good way to make a lot of money. It's doing
but some of these things are being actually like thought through by academics and like professor types, and
Well, Vajanath has a question. So, hey, Vajanath.
Yeah, hi, Greg. Hi, Omar.
Hi.
Yeah, we were discussing about the archive nodes. Okay, so setting up the archive nodes is mainly left to a public in mainnet launch or in AlphaNet also. In AlphaNet, public is able to have archive nodes.
Well, so in the AlphaNet, there is no public run nodes at all. But during BetaNet, we can have the public run.
For validator nodes, we have come to a conclusion that it will be costing around $50 per month to set up a validator node. So,
yeah, I mean, so
cost to set up an archive node.
So probably be about 10x that. So maybe around 500.
Yeah. So our archive nodes is probably more where like institutions will gravitate, or like just not the average retail person. Average retail people will gravitate to validator, and maybe some people that are a little bit like that just can afford the $500 per month, if that's what the figure winds up being, would do the archive nodes. But it's also important to remember that archive nodes aren't involved in consensus, so it's okay for just a few people to be operating those archive nodes.
Yeah. So
Omar,
one question
it looks
is,
like
if archive node can be set up during the main launch or after the main launch of the Shardeum, so if I, as a person, set up more number of archive nodes, and how that 51% attack will be taken into care? I can set up a more number of archive nodes and I can attack the node immediately after the launch.
Yeah, I mean, but the team will also be running some archive nodes always, and and some, I'm sure like some of the VCs that will be investing in Shardium, they are very interested in running nodes as well too. So so people that have a vested interest in Shardium will also be running archive nodes to ensure that the network is safe.
Yeah. So the archive nodes don't communicate with each other, right?
They do some communication, but they don't do consensus, right?
Yeah.
So
like a 51% attack doesn't matter at the archive node level.
Yeah, with the archive node level, you have to do 100% attack, right, to really impact the system. So
even if you own 9 out of 10 archive nodes, if you take all 9 out of 10 archive nodes offline, there's still one archive node up that stores the same data, and you could just simply add more. Shardium Foundation could add other archive nodes, or other people could.
Yeah.
Yeah. Thank you.
And yeah, go ahead.
What is the block size of Shardium? Like Bitcoin has 1 MB of block size. I don't know the block size of Shardium.
Yeah, actually, we mentioned in the light paper that with Shardium, we're not using blocks, and we're not doing consensus on the block level. So some people then immediately think like, okay, maybe it's a DAG, but we're also not a DAG. We're doing consensus for each transaction independently, but we're doing that consensus using proof of quorum, where it's just a group of nodes that need to handle that transaction. They come together and basically vote on whether to accept the transaction or not, and that collecting those votes, you can generate a receipt, and that receipt basically is your proof of quorum. And so then, you can use that to commit to a transaction. And so you have immediate finality on the transaction. And once, we have a commitment for the transactions, we group transactions into blocks later, and then, we store it that way, right? So we don't So with Shardium, what's going to happen is like rather than grouping transactions into blocks before you do the consensus, we do consensus on each transactions and then group them into blocks later. And the blocks would be based on like a range of address that we call, a partition, and then also a duration of time. So all transactions that, are involved with an account within this range of address and which happen to occur during this duration of time, those transactions will get grouped together. And so there'll be lots of, blocks like this being generated simultaneously.
So basically, there is no fixed size as of now.
Yeah, there's right. So there's no fixed size for that block. Yeah.
Okay.
So, and Omar, I just want to clarify something as well. So we validate transactions on the individual transaction level, during consensus, to ensure atomic processing of transactions. But then after consensus, we're grouping these transactions into blocks to, sort of like compress the data being sent to the archive nodes. Is that why it's grouped into blocks after consensus?
Yeah. And also what happens is, since they all get like interconnected through hashes and so forth, then it makes the earlier, data like completely immutable, right?
Got it. Cool.
Thank you.
Mm-hmm.
Siddharth, any questions popped into your mind yet, or Shram, Venue? Go ahead, Shram. Just need to unmute your mic.
Hi, Greg. Hi, Omar, and hi, Dan.
Hi.
I want to know if the transactions, Shardeum has a transaction level consensus, and if these transactions are, being committed to a block, how does the since transactions are happening simultaneously, are being validated simultaneously, how is it ordered on a first out basis, and how do these shards communicate with each other to maintain the atomic composability, as you guys refer, of the network?
Mm-hmm. Yeah, good question. The transactions are processed independently of each other, and so when you want to do consensus, there's really three parts to consensus. And typically what happens in like a blockchain system, it gets done all together and people don't recognize that there's really three parts to consensus. But when you when you have a network that's sharded, you have to think about each of those components separately. So initially, one of the things that the nodes have to consensus upon is the ordering of the transactions. And in, proof of work network where everything goes into a block, there's only one stream of ordering, right? So the order in which the transactions appear in the block determines that order, and then, blocks are then ordered, sequentially. And so every transaction is absolutely ordered relative to all other transactions. Now, if you think about a sharded network, there's no such thing as absolute ordering of transactions because, some transactions may not, may be happening in some shards and other transactions happening in other shards. And you really can't talk about like which came first or second, especially if these accounts don't directly interact with each other on that same transaction. So, you can have lots of parallel transactions being processed like that, and we do that, and that's what gets us the higher TPS. The only time ordering really matters is when two transactions are trying to access the same account, right? And so for that, what we do is we ask the client to include a timestamp with the transaction that they submit. So that would be, signed along with the rest of the transaction. And if a client can't do that, then we have a simple algorithm to have the network timestamp the transaction. And so every transaction then is basically timestamped. And if there's a collision in the timestamp, then we use the transaction hash to break the timestamp or to break the tie. And so that, so then we kind of also get an absolute ordering in some sense, but it really matters only for transactions that are related, right, and accessing the same account. Now, the other thing that needs to be consented upon, in addition to the ordering, is, is this transaction valid, right? Unfortunately, that's a fairly easy thing to consent upon, because if you have honest nodes, then they should all be agreeing on whether that transaction is valid or not. And then the final thing that you need to consent upon is was this transaction seen by a sufficient number of nodes within the processing time to actually be considered as having been processed, right? And so that is determined by whether or not a receipt can be generated. So if the nodes, when they see a transaction, they decide whether to accept it or reject it, and then they put a vote out, and they're collecting votes from the other nodes. And if they get more than 50% of the nodes voting the same way, then they can build a receipt, and they can, based on that receipt, know that this transaction can be committed. And if some node, for example, let's say, didn't see some votes and thought that I didn't get enough transactions to build a receipt, well, that node would eventually find that it's out of sync, and then another node could prove to it that a receipt was generated, and then it could update its state. And so so those are the 3 parts to consensus, and we kind of have to think about all of these separately in a sharded network, whereas in a blockchain type network, they kind of get tightly coupled and done together.
Thank you. Thank you so
much. Your question?
Yes, it did. Thank you.
Looks like Vajranath has a question, and there's some questions in the chat here. I have to run. I start traveling tomorrow at 7 a.m., so I've got to spend some time with my wife today, but hope you guys enjoy the rest of the conversation, and please keep asking questions, Omar.
Yeah, definitely.
Omar questions, so he doesn't have to come up with conversation topics. Thanks, guys.
Enjoy Amsterdam.
Yeah, thanks a lot for joining.
Bye.
Thanks, Dan.
Bye, guys. Tips, hit me up.
Yeah, Vajranath, you had a question?
Yeah, Omar.
Mm-hmm.
So, based on the transactions we were discussing, in Bitcoin chain, we have a mempool, which miners will create a mempool. Basically, the transactions which are not got a finality yet into the blockchain. So, is there any mempool in Shardeum?
So there isn't a mempool in the way that like we have in, say, Bitcoin, right? So Bitcoin, if you think about the architecture of how Bitcoin is set up, it's set up to always, provide accessibility, but not necessarily have like consistency, right? So what that means is that, for example, let's say there was a network failure between Australia and the rest of the world. So the nodes in Australia would continue trying to create blocks, right? And the nodes, of course, in the rest of the world would also be creating blocks, and you would get this, divergence. But so for somebody in Australia submitting a transaction to one of the local nodes there, they would think that their transaction got processed and put into a block and so forth. So that means their network is available, right? So it's not down. But then what happens is that eventually when the the network line is fixed between Australia and the rest of the world, the nodes in Australia find out that, hey, the chain that we created is much shorter than the chain that the rest of the world created. And so they have to like orphan all those blocks and then switch over to the longer chain, right? And so then that's when you get consistency, you have eventual consistency, right? So the nodes will eventually come back to agreement on, what everybody has agreed. And so, the other model that you can use is that you can opt for consistency always, but you sacrifice on the availability, right? So when there's a partition between, say, Australia and the rest of the world, the nodes in Australia will say, we can't process the transactions anymore. And maybe even the nodes in the rest of the world will say, well, we don't have enough nodes to, generate a receipt, right? So the network basically tells the users that, hey, we can't process the transactions. You're going to have to try again later. But the network maintains consistency. And so you sacrifice availability in order to maintain consistency. So that's the model that Shardeum is using. And so with that model, we never have to worry about like maintaining this big backlog of transactions that we have to process, right? So we can basically provide an SLA on the transactions and say like, hey, your transaction will be processed within 5 to 10 seconds. Otherwise, it's not processed, or the network tells you that it's too busy to process the transaction, is rather than just taking all the transactions in and then processing them whenever. So I think that's actually a good feature, because having actually used these networks, like Bitcoin and Ethereum, I've had many situations where the network was very busy and I submitted a transaction and maybe my gas, wasn't high enough to get that transaction processed in a minute or two. And then pretty soon I'm waiting for like hours, and, sometimes people have to wait for days. And, then, you start changing your mind and you're like, okay, let's, either get this transaction to go through or let's cancel this, right? And so if you look, if you've ever encountered this, you see that MetaMask has this option to either speed up the transaction or cancel the transaction. And, people just don't like being in a situation where they've submitted a transaction, but it's not going through for days, right? So, so I think the model that we've chosen for Shardeum, I think that's, people will actually like that model better.
Yeah. So immediate finality of the Shardium, is that correct for this matter, what we have discussed now?
Yeah, exactly. So yeah, because we have immediate finality.
don't have to maintain a mempool.
Right, exactly.
Okay, thank you.
Mm-hmm. Any other questions? So, maybe we can talk a little bit about the node reward system. And, as I have been thinking about this more and more, we and the community has also been, providing a lot of good input on this topic. There's a lot of a simplistic approach where you have like a completely rule-based node reward system, like what Bitcoin has. That it's easy to understand, but there may be situations where oops, somebody needs to mute their mic.
Hey, fellow Jester.
Oh yeah. Okay, there we go. Okay, cool. Thank you. Yeah. So, with the node reward system, having a completely rule-based system like what Bitcoin has, it's easy to understand and so forth, but we don't know what the long-term consequences of these kind of systems would be like. And even in Bitcoin, we don't know what's going to happen really when let's say we get 100 years down into Bitcoin, and there's like less than one Bitcoin left to be mined. What if there isn't sufficient transaction fees to support the miner ecosystem? And then if the miners start pulling out, then the transactions get slower and users don't like that experience, so they move to other networks, and then now you have even less transactions, and then it kind of gets into a vicious cycle. And people have actually written some blog posts and discussions about this, and this is referred to as like what is that, the cycle of death or something like that, where it's a negative cycle and it just kind of leads to the network getting less and less usage, and then less transactions, and then less a reward for the miners, and the miners start to turn off their systems and so forth. So we don't know what's going to happen long term. Now the other aspect is that we're not using proof of work, we're using proof of stake. And so with proof of stake, it adds kind of new dynamics, and Dan brought this up when he made that post, where unlike proof of work, where somebody has made a more of a commitment by purchasing hardware, exiting the network is more difficult for them. Because now they have to, sell that hardware before they can actually like exit the network. But as long as they have the hardware, they'll still continue to mine with it. With proof of stake, it's really easy for somebody to just sell their coins on the market and exit the platform, right? So that makes it where we have to think a little bit more careful about something like a vicious cycle being able to develop much more easily in a proof of stake system. And so based on that, we really have been thinking that it would be really difficult to kind of like design a system that you just like pre-program and just say like, okay, this is going to run for the next, 50 to 100 years and, without failure. And so I'm really seeing that we're going to need a system where, there might be some involvement from the community, even when the system is running, where, we have certain knobs, like, what's the daily mining reward? What's the amount that we stake? Things like that, that we can tweak to adjust this system based on what's happening, right? And eventually a DAO would be doing that, and the foundation would still be there to execute what the DAO wants. Initially, I think the foundation can do this, and we can also have some rules around it, where there's some guidelines on, like, hey, never make this parameter below this value, or never exceed this value for this parameter, kind of things, right? And so that's what I'm starting to think. And also what I'm noticing is that, you can't just think about the node rewards in an isolated way. It's tightly coupled with, the staking, and, it's tightly coupled with the slashing, right? And it's also tightly coupled with the growth of your system in terms of the total locked value on the platform. So there's a lot of details and complexities when you start to think through this system. And, Dan and I are kind of discussing these things and, kind of writing up something. But we also, welcome the community to think about it and put out, ideas that they have. And ideally, if you really want to contribute and you really have thought through this a lot, I really would recommend other people to also think through these topics and, write up a paper proposal. Don't just think that, Omar and Dan are going to do this. No, what would be really good is if multiple people did this, and we sort of see, like, what are the similarities and differences in these proposals, and that would help us, build a better system in the long term. So, really invite everybody to, think about this and independently, write it up and, put something out there. And this is how things get, better, and, having more people, having more minds thinking about it will definitely allow the end result to be better. So, but yeah, so that's a lot of talk about, what we're doing. So, again, in summary, we're still thinking about this. So there's, still time for a lot of people to also think about it and start writing proposals and put ideas out there.
And I think just to add to that is we have discussed this quite a lot, and there might be the thought that we are further down the line and that this is almost decided, but it really isn't.
No.
Like Omar said, we almost want to get to consensus on this, but we want to do it via the community. It's not something we can really just vote on because it's too complicated just to vote like we're doing with the fork names. So if individual people were to come to a very similar conclusions with their own papers and their own ideas, that would give us a lot more confidence in that our chains of thought are correct. And just again to echo what Omar said about having a reward structure that is set out from day one that just operates forever. It's obviously hasn't been proven that as work with Bitcoin, but if we take Avalanche, for example, with their the amount of their token that needs to be staked in order to join as a validator, they've immediately run into an issue because they can't quickly change that. So it's immediately just halted the progress of their network until they work out how they're going to do that. So I think as many of these variables as we can have that are within logical kind of parameters so things don't go too crazy is probably the route to go down. But how that looks, And again, there's so many other parts to it because you've got the initial issuance. So how it needs to be so many things to so many people. You've got it needs to reward early adopters. So we want to obviously get nodes and whatnot into the network early because that's how we're going to grow. It also needs to be, the inflation needs to be at a decent enough level over time that the initial VCs don't feel like their investment is being diluted. But longer term, the network needs to be able to sustain itself on maybe just transaction fees, or maybe we have a burn mechanism that we don't know about just yet, but it's again up for debate. But it's really trying to work out how this works long term. And to be honest, it all hedges on the adoption of the network and the adoption of the network. And to be honest, it's impossible to predict that. So by having these parameters we can tweak, we can make sure it is as good for as many of those purposes as possible. And I think that's the complexity, Omar, that we're trying to work out, that you're trying to please a lot of people with something, and I don't think there is a perfect answer. So I think that's like a hard topic.
Yeah, absolutely. And, this is, the more I think about this, the, more I realize that, how many different things are like tightly coupled in this, right? Like I mentioned, it's just, you can't just think about node rewards in a black box and think that, nothing else impacts it. Of course, the amount that a node has to stake impacts it, right? Because imagine if you're asking a node to stake, like $50,000, but then over the course of the year, maybe the node only earns, like say $1,000, then that's just not gonna, if you look at the APY of that, it's gonna be like, oh, I'm making 2% a year for what I'm staking.
Off to another
That's
network.
not going to be very attractive, right?
Yeah.
So the staking amount impacts the node reward, but then you need a node to stake enough such that you can actually slash it, right, sufficiently to make it like worthwhile to stop the node from misbehaving, right? Because like imagine if you're only having to stake like $500. Well, a node could misbehave, and like even if you slashed 100% of its stake, it's not a big hit for that node. It can take an attempt to like say, do something malicious, and if it gets caught, then okay, yeah, I lose $500, right? So you want that staking amounts to be high, and then also you have to look at the overall, the value that's locked on the network, right? So as the value that's locked on the network goes up, you need nodes to be more and more vested in the network, right? Because like even a $5,000 or $10,000 staking amount, if the TVL, goes up, becomes insignificant. Right? Because if I, subvert the system and I can now access billions of dollars, then I don't mind, taking a chance with say $5,000 or $10,000 to do that, right? So you keep having to, like if the TVL goes up, the staking amount will have to go up as well, right? And now if the staking amount goes up, then the node reward has to go up. And if the node reward goes up, then, you're paying more for the whole, maintenance of the network, right? For the infrastructure for that network. And, that ties into, other things like, well, then is there sufficient transactions happening in order to offset that? Because, long term, you want to reach a steady state where the amount that you're paying out in node reward can be equal to the amount that's being spent on transaction fees, right? And so, so there's a lot of like things that are tightly coupled, and have to be thought through. And, ideally, I think there is no ideal system that we can just like preset and say, okay, this is going to be able to run forever. I think what we're going to have to do is like start to recognize this and then, think about, how these things interact with each other and come up with some formulas for these things and, have some guidelines on how it should be done. And then at the end of the day, work towards developing a model where, these things can be tweaked while the network is alive without having to do any kind of, major interruptions or anything like that to the network.
It's basically like a really, really complicated balancing act, like you said.
It is.
And I've got a question for you.
Mm-hmm.
So you mentioned the staking amount is a part of this as well. And if you stake, say, $50,000 or the equivalent of what it would be in SHM, and the return is only, say, 2%, that's a very unattractive proposition. What are your thoughts on if it goes the other way? So the actual yield is huge. So the network then ends up attracting a vast amount of nodes that you don't necessarily need. So they would sit in standby. Is that advantageous or is that inefficiency? Because I've thought about this and it's both, I think, but I'd be intrigued to know what your thought is on that topic.
Mm-hmm. Yeah, I think in some ways it's an advantage because the more nodes that you have that are attracted to the system, even if they're in standby mode, it does increase the decentralization level of the network, right? So that is an advantage. But then, you have to think like, hey, are we spending more than what's really needed? Like, do we need that level of decentralization, right? I mean, it's, just as there's, I think, an excess in terms of redundancy, I think it's also possible to have an excess of decentralization, right? Beyond some amount. And so then, you could actually think that, well, maybe we should tune down the node rewards and in such a way that we can still have sufficient decentralization, but then we're not overspending on, the maintenance of the network. So
then you've got that environmental part of it, that you're potentially sitting with thousands and thousands of extra nodes, and I suppose it's still hardware, it's still electricity, it's kind of inefficient from a network perspective.
Yeah, I mean, to some extent, but the essence of it though is that eventually the network has to pay for it, right? Like we have to pay for whatever, these nodes are not there because they're losing money. They're there because they're making money, and somehow that money has to come from somewhere, and the network has to pay for it, and so just like switching off the lights when you're not in the room, it does make sense to like reduce your expenses if you don't really need that many nodes.
It's almost like the Goldilocks problem. We need the network. It's why you need it to be so kind of adjustable. The certain rewards need to be not too high but not too low, and I suppose at any given time there is no way of us actually predicting what that is, hence needing to be fluid, I suppose.
Yeah, exactly, because like we don't know how fast the TVL is going to grow. We don't know how fast the price of SHM is going to change. Of course, with these coins, you have very fast spikes, and then periods when there's bear markets and so forth. So I think it's going to be important to be able to adjust to these situations and having some key knobs that the network can tweak. So far, the key knobs that I'm seeing is really the daily node reward amount that we give a node. That could be measured in various ways, but it's, how much SHM, and actually you can measure it in terms of like the dollar amount, because that actually is easier to understand, because, at the end of the day, people are paying for the hardware in terms of dollar amounts and not directly in SHM. So they're going to want to, calculate that by looking at what is the price of SHM relative to a stable coin. So one of the key parameters is, just the amount of SHM that you give over time. The other one is, what dollar amount of SHM needs to be staked in order to become a validator. And then the third one is like the minimum number of nodes that we want the network to have, right? So even in a scenario where, like, let's say there wasn't a lot of transactions happening, but you still want the network to have a certain amount of node to maintain a certain level of decentralization, right? And so those kind of, those I think are like the key three main parameters that I've thought of so far that like a DAO or the foundation can tweak to adjust this. And then the rest of it is pretty much like out of our control, the price of SHM, the value that gets locked on the network, how many node operators want to come to the network and things like that. So,
and I think the one key takeaway from this, hopefully, is that there's a lot to discuss and that anybody can contribute to this. This is this open collaboration piece. So please, if you're in the community and you think, I've got an idea, share it, write something about it, reach out to one of us, and we'll definitely take all kind of guidance. So yeah, I think there's a really good question in the chat around what is a malicious node, what will be treated as malicious, and what kind of the outcomes if we identify a malicious node. I'll let you take that because you'll explain it a million times better than me, but it's a very good question.
Yeah. So that's also, something that we're working on in terms of like what types of activity can be recognized as being malicious and, slashed for. Like one obvious one is like if a node voted, for the same transaction, voted like multiple ways, like saying, hey, this transaction should be accepted, and then also voting and saying that it should be rejected. And in particular, it could try to like send the one vote to one set of nodes and send the other vote to another set of nodes, and cause that transaction to not be processed, or cause difficulties for nodes where you're trying to get the network to have a partition in terms of what its state is. So those kind of things can easily be caught because the nodes gossip the votes to one another. So even though this node only sent that vote to one set of nodes and didn't send it to another, because the nodes are gossiping the transaction around, eventually all the nodes would see it, right? So something like that could be detected and then slashed for. Another activity is like let's say you're trying to like the recommended hardware for running a validator is like, let's say X, but you're using like half of X and trying to get by and cut your costs. But then like say the traffic on the network picks up and your node is not able to keep up with that traffic, right? Because it's getting really slowed down processing those transactions, and the response from your node is much slower than what the rest of the network is doing, or you put it on a bad network, like maybe you're running it out of your bedroom or something, and you have a flaky network where other people in your house are watching videos, and your bandwidth is fluctuating, and so sometimes your node is not able to participate properly. So what we can do is have other nodes in the network keep track of how your node has been responding to them, and based on that kind of when it comes time for your node to ask for a reward, that their nodes may actually vote to slash you at that time because you weren't participating right during that time, and so that kind of activity could get detected, and that would be a way to enforce node operators running nodes that are good quality nodes as opposed to running like the cheapest hardware that they could find to get away with, right? So that's another activity that could be slashed for. Another is when a node could come in and become malicious in terms of say, hey, I'm just not gonna do any voting, or I'm not gonna gossip these transactions and things like that. So those are kind of a little bit harder to detect, but if you especially if you have a scenario, especially where another node is asking you to provide some input, but you're refusing to provide it, then those kind of things can get detected. So these are just some of the scenarios that I'm thinking of off the top of my head. But I'm sure as we go along, move forward with the network, we'll come up with other things as well.
It's probably worth.
I think there's there are, and as you said, there are different protocol situations where that your node didn't do the proper duties of the validator, or
Right.
it did something against the protocol that the rest of the network detected. These are the main things. But there are other things if you go lower in the P2P layer level, for example, if some node is trying to do or trying to send protocol messages which are not properly aligned to the rest of the network, so this will eventually get rejected, and this will get noticed by P2P. And so it's sending it's saying how many bad messages that this message has sent to me, right? And after a threshold, you actually you have cut the connection with that network, and try to isolate the network from the, or isolate that node from the network, which is also a slashing event, right? So
Exactly.
so it can happen at multiple levels. One is at the network level, where you are sending, if you're trying all this stuff, and then the second is at the application level.
Right. And in Shardium, typically what happens is that rather than a node dropping a connection with the node, that kind of scenario happens in say Bitcoin or Ethereum, where you have that local view model. But in Shardium, where we have a global view model, what happens is that the nodes will actually vote to kick this node out of the network. So, yep. Yeah, and then of course, there's the whole discussion again of what amounts should be slashed, right, for these different types of behavior. That's a whole area of research as well. So yeah, so detecting misbehavior is one, and then after that is how much do you slash for different types of behavior and so forth. That's another whole category to look at as well. So
there is a question in the chat that I missed, so apologies, from an Earth, I think, hopefully that's how you say it. And it says, an actor pushes his transaction with higher gas fees than the rest, basically creating gas wars for time-sensitive contract interactions. Is there no priority for acceptance on first-in, first-out basis rather than availability of nodes to process it?
Yeah, absolutely. So that's one of the nice things of Shardeum is that, the gas fees are basically, or the gas price is constant, right? So everybody pays the same gas price. Now, the amount of processing that your transaction does could end up costing you more or less, but because we've designed the system so that ideally it's always it has an SLA, like we'll process your transaction right away or we'll reject it, and so there's no like a pending queue where we have all these transactions queued up and we'll eventually process them. We don't do it that way, and so with that model, we can say that everybody has the same gas price, and so that makes front-running transactions more difficult.
Hi, Omar. I have another question.
Mm-hmm.
So Nishal spoke about, published a blog about proof of NFTs, and will Shardium be implementing that kind of consensus?
I mean, I think Nishal is kind of just talking at a high level about, use cases for NFTs and, possibly using them for staking almost, right? So like how we have, our current model is where you would stake SHM in order to run a validator. But, he's bringing up some interesting use cases for NFTs, which I think, haven't been done before, which is like, what if we can use NFTs in order to, run a validator, right? So you stake some NFT to do that. Now, the interesting part of it is that if there's identity tied with NFTs somehow, and, there's people doing work on, tying identities with NFTs, then what that could do is kind of ensure that like one entity doesn't run like too many nodes, right? I mean, maybe we would allow them to run
exactly
2 or 3 or something like that. But if we could identify based on an NFT that, hey, this is the same person, then, we could reduce that risk of like, where you lose decentralization because it's the same entity running lots of nodes, right? And so I think that's a very interesting use case, and I'm sure there's a lot that still needs to be thought through with how this model would work. So.
Yes, indeed. I think we can explore a bit more about this in detail with the community. And like Nishal stated, that this also introduces a gamification of rewards, wherein people will collect rare NFTs in order to get more chances of validating and more chances of rewards. And they will also sell these NFTs, sell SHM coins in the open market. Thereby, this reduces the accumulation of coins, and this is similar to what proof of stake Bitcoin miners do to pay back their electricity bill so that they can keep running their nodes. So I think this is a really good use case for it.
Yeah, definitely. Yeah, it's definitely an interesting use case of NFTs, and it's cool that Nishal has proposed that, and we'll see. I think we definitely should discuss it in the community and see what people think about this. So,
Sure. Thank you for answering.
Mm-hmm. Okay. So any other question, guys? It's really fun doing these Saturday morning talks. Morning for me, evening for you guys probably. But we get to see a lot of perspectives, and you guys are asking really good questions. And I hope we can continue this, and we'd definitely like to have community input on topics like node reward and staking and slashing and things like that. And really even if you post like say just some a few sentences or something like that about what your thoughts are, or some issue that you can think of related to this, that's helpful. But what would really be helpful is like if somebody really sits down and writes up a paper and thinks through a lot of this, and then puts out a proposal like that. That really becomes something that others can try to digest and really think about, like maybe implementing that proposal, or comparing that proposal with other proposals, and seeing what the similarities and differences are. So Dan, you want to like maybe cover like the questions, because I think there's still some questions in here. Like if you can maybe read them out and see which ones we want to cover. Oh, Dan is probably restarting his computer.
Omar, did you address the question on malicious nodes and what things are treated as malicious nodes?
I think we did. Yeah, we had a discussion, about that.
Then,
Yeah, who was that?
Yeah, myself, Vaijanat,
Okay.
And
yeah.
We discussed there's a no mempool in Shardeum, and there's a immediate finality. So nodes running a Shardeum network, is there a chance the two nodes mine a single transaction, a duplication of the transaction?
Yeah, so it doesn't quite work that way. So what happens is a transaction, will have an access list with it, or it can be determined to some extent, and based on that, what accounts this transaction is accessing, it gets routed to the appropriate shards which hold that transaction, and then the nodes in those shards form a virtual consensus group, and then that's where we vote on whether or not to accept the transaction and generate a receipt, right? So with that kind of a way of doing consensus, we don't have a scenario where a transaction could be processed, like say in one shard but not processed in another shard.
Okay, thank you.
Mm-hmm.
I don't see any other questions, Omar bhai. I think you answered all of them.
Well, there was this one I'm reading right now. It says, I came across ETHScan, which does parametric insurance by the ticker of DIP. They decided to make stake. Okay, so this is just some comment. But yeah. Okay, cool. Yeah, I really appreciate you guys joining today and, asking the questions and sharing your thoughts. So we'll try to continue again next week, and hopefully we make some more progress on the node reward system. So great.
Yeah.
All right.
Thanks, Omar.
Yeah. Take care, guys.
Bye, everyone.
Thank you, Omar.
Enjoy your weekend.
Bye.
Thank you.
Oh, bye, Ingamals.
Hello.
Yeah, we are just ending this session, Ingamals.